Okay, in this video, we're going to talk about some trigonometric word problems. One of the reasons I'm having you watch this video is so that we don't have to do any teaching on the day before Thanksgiving. So we'll do the teaching right here in this video, and then we'll try some example problems for a homework assignment when we get to class tomorrow. So we are going to be using the calculator for these. So first thing I'd like to talk about is how to do some basic trig stuff on the calculator. Some of you guys maybe have seen this before in trigonometry, in geometry. But we'll review it right now. So let's say, for example, that we had the equation sine of 32 degrees is equal to 5 over x, and we needed to solve for x. All right, well, this is basic algebra to start out. If I want to solve for x, the first thing that I have to do is I have to get x by itself. So in order to do that, I would need to multiply x on both sides of the equation. So I'd have x times the sine of 32 degrees. And then algebraically, to get x by itself, I have to divide by the sine of 32 degrees. That's how I'm going to get that to cancel out on both sides. So I've solved for x. The next thing that we want to do is we want to plug this into the calculator. So this is where the calculator will come into play. Now, what you'll notice is that this problem that we're doing is in degrees. So the first thing that we're going to have to make sure of is that our calculator is in degree mode. So what you'll notice if you pull up your calculator, if you press the mode button, if you scroll down to this line right here, there's an option to have your calculator in radian mode or degree mode. Typically on word problems, you're going to want your calculator in degree mode. So I'm going to go and highlight degree and press enter and make sure that my calculator is in degree mode for all of the questions that we will do throughout this video. So if I press second and quit, that gets me to the home screen. And again, what I'm trying to plug in right here is 5 divided by the sine of 32 degrees. And when I do that, I get an answer here of, we'll round to 3 decimal places, 9.435. Okay, 9.435. Okay, so I can use the trig functions on the calculator to help me solve. If I already have the angle, I just use the normal trig function to ask the calculator to find the sine, cosine, or tangent of that angle. I'm going to go ahead and put this in here so everybody can see how I type that into the calculator. All right, next up, there's one other scenario that you might need to be able to work with when it comes to solving. Let's say that instead I had something like tangent of theta equals 3 over 7. And I said solve for theta. Okay. Well, the difference on this problem is that on the last one you had the angle and you had to solve for essentially one of the side lengths in the ratio. On this one we have the entire ratio and we have to solve for the angle. Now we've talked about how we do this, and it's using something called an inverse trig function. So in order to solve for theta, what we're going to have to do is we're going to have to switch this around and put it in its inverse form. And what its inverse form is going to look like is tangent to the -1 of this ratio, or you could write this as arctan of 3/7. Okay, so what this says is find an angle that has a tangent value of 3 over 7. And I'm going to ask the calculator to do this, and there is a button that will allow me to ask the calculator to find this for me. I just have to make sure I know how to use it. So we've solved for theta right here, but we want to get an actual answer. So let's come over here and let's pull this up on the calculator. So what you'll notice is on the calculator, sine, cosine, and tangent, above them all have a sine to the -1, cosine to the -1, and a tangent to the -1. Anytime you're trying to solve for an angle and not a side, you're going to need to use that inverse trig function. So the way that we get these blue functions on the calculator is we press second first. Okay, so we press the second button and then tangent. What it's going to do is pull up tangent to the -1, and then I can input that ratio. So what I'm asking the calculator here is what angle has a tangent value of 3 over 7, and when I press enter, it will give me this angle. Let's go ahead and copy this here. We'll put this into our presentation. You'll see underneath there a word problem. We'll get to that in just a moment. Okay, so let's write down this answer here. So if I round to 3 decimals, this would be 23.19 5 rounds up. So 8 goes to a 9. Now, we don't want to just write this because this is an angle, and this angle is in degrees. So there's my final answer for that. So, moral of the story, if you're trying to solve for a side length, you just use normal trig functions. And if you're trying to solve for the angle, that is when we use the inverse trig function on the calculator. All right, now why am I showing you that? Because in order to solve any sort of trigonometric word problem, you might need to do either one of those two functions, either a normal trig function or an inverse trig function on the calculator. So now what we're going to do to finish this video is we're going to look at a couple of word problems, okay? My number one hint on any word problem, before I even read this, I'm going to write, hey, draw a picture, because if you can draw a good picture, then you can solve a trigonometric word problem. People hate word problems because there's a lot of information to sift through. You got to keep a lot of things straight in your head, but if you can write it down, it's going to be easier to come up with some sort of equation that you can then solve for whatever variable they're asking for. So let's look at what this says. This says the angle of elevation from the top of a 10-foot statue to the bottom of a needle on the roof of a 500-foot tall building is 27 degrees. How far is the statue from the base of the building? All right, well, let's draw a picture here. Let's say, here's my statue. Okay, I've got a statue of a person. Okay, what they've told me here is that this statue is 10 feet tall. Okay, and then we have a building over here. This is obviously not drawn to scale. That has a needle on top of it, and they're telling me, hey, this building is 500 feet tall. Okay, and they say that the angle of elevation. Okay, and all an angle of elevation is the angle from the horizontal up. So if I draw this from here to the bottom of this needle, what they tell me is that this angle of elevation right here, which is this angle from the horizontal, is 27 degrees. Okay. Now the question wants to know, how far is the statue from the base of the building? Well, the base of the building is like this side of the building right here. Okay. Or in other words, it's this distance. Okay. How far is the statue from the base of the building? So what we're really trying to figure out right here is this side length. Okay. So if you want to call this something, let's call this x. Okay. I'm trying to solve for x. And again, this is a terrible picture in terms of me drawing it to scale. But if I want to think about the sides that I have and what I need to solve for, here's what we can think about. What we want to know here, really, in order to set up an equation is, what is this length here? Okay, well, the total height of the building was 500 feet, and the height of the statue was 10 feet. And again, I did not draw this super well to scale, but what that means is if I wanted to find this height right here, well, it's 500 feet, the height of the building, minus 10 feet, the height of the statue. Okay, so that height right there is 490 feet. So if we think about this triangle that I've created here, because I have created a right triangle, what I can do here is I can set up an equation using this side, and this angle. Well, think about this. In relation to the 27 degrees, the side that I'm working with right here, this side over here is the opposite side, and this side that I'm trying to solve for right here is the adjacent side. Well, when you see opposite and adjacent, the very first thing that should come to your mind is tangent. Okay, so I can set up an equation here for tangent, and I can try to solve for that missing side. So let's try it. The angle that I'm working with is 27 degrees. So I have the tangent of 27 degrees is equal to, if I look at my opposite side, O over A, opposite side is 490, and the adjacent side is X. So all I got to do is I got to solve this equation for X. So let's try it. If I multiply both sides by X right here, okay, and then if you want to kind of do two things in one step, I could then divide both sides by the tangent of 27 degrees, okay. When I'm done here, I get X is equal to 490 divided by the tangent of 27 degrees. And the calculator can help us calculate this. We have the angle, so we are just going to use the normal trig function. We will do 490 divided by the tangent of 27 degrees. And when I'm done here, I get an answer of 961. We'll go ahead and again put this in our presentation. Put this in our notes, I should say. So 961.679, and The only other thing that we're going to want to do here is this is a word problem, so we need some units. So 961.679, and what would our units be for this? Well, this is a distance, and it said that in this problem we were using a unit of feet. Okay, so I'll go ahead and label this 961.679 feet. Okay, so there's my distance from the statue to the base of the building. All right, so on this problem we were solving for a side length, so we ended up using the normal trig function for tangent. Let's take a look at this next one. Okay, last example here in the video. So it says Tim is trying to shoot a projectile from 3 feet above the ground into a hole that is located 20 feet away. Space this out just a little bit so that we're not mixing it with what we've got in the last problem. So into a hole that's located 20 feet away. If the diagonal distance from the projectile to the hole is 27 feet, at what angle should he fire the projectile to make it into the hole? All right, well, let's see what we're working with right here. So we've got a projectile. We'll draw a cannon right here. And so we're saying, hey, this cannon, if this is the ground, the cannon is 3 feet above the ground. Okay, and then we've got this hole that's somewhere over here. Okay, and so we'll say there's my hole that I'm trying to shoot this into. And we're saying that the hole is located 20 feet away. So if we want to label some stuff here, this distance right here is 20 feet. Okay. And it says the diagonal distance from the projectile to the hole is 27 feet. So from here to the hole, this diagonal distance is 27 feet. Okay, and what this wants to know is at what angle should we fire the projectile to make it into the hole? Well, one thing that I would ask you guys and challenge you to think about on this problem is, does it really matter how high this is above the ground? Let's think about it. All we really need to know is that this distance here is 20 feet. Okay, and as long as I know that that distance right there is 20 feet, then I'm good to go. And I don't really even concern myself with the fact that it's 3 feet above the ground, because guess what? I already have two sides of this triangle. I have this side and I have this side. Okay, if we want to break this down into really simple terms right here, here's the triangle that I'm looking at. I'm looking at a right triangle where this is 20 and this is 27. And the question wants to know, well, at what angle should we fire this thing? So that's this angle right here. Okay, I'm really trying to solve for that theta. So if I want to solve for that theta, let's set up a statement or an equation that involves those sides of the triangle and that angle right there. Well, if I look at this simpler triangle that I've drawn, if this is theta, down here on the bottom left, this angle right here is the adjacent side, and this angle right here, not touching the right angle, is the hypotenuse. Well, when you see adjacent and the hypotenuse, the very first thing that should come to your mind always is cosine. Okay, so if we had to set up a statement here, we could say cosine of theta equals adjacent 20 over hypotenuse 27. Right? Now on this one, the difference is compared to the last problem, we have the side lengths, we're trying to solve for the angle. So in order to do that, we're going to need to use inverse cosine. So theta is going to be equal to cosine to the negative 1 of 20 over 27. So I've solved for theta. I just want to figure out exactly what that value is. And the way that I can do that is by asking the calculator. Remember, in order to get those inverse trig functions, we need to press seconds and then whatever button we're trying to use. In this case, it's cosine. So cosine to the negative 1 of 20 divided by 27. So I'm asking the calculator, find me an angle that has a cosine value of 20 over 27. And when I'm done, it gives me an angle of 42.205. And this is going to be in, put this in our notes right here, 42.205 degrees. Okay, so if you think about, hey, how do they program lasers to be in different spots? How do they program lights to shine in the right spot? This all comes down to thinking about angles and using normal trig functions and inverse trig functions to try to figure out correct angles and side lengths. Okay, so there's a little bit of practice with trig word problems, some examples, and we will do some more practice in class tomorrow, and you'll have a good rest of the day. Thanks, guys. Bye.